In this lecture, we're going to learn about precedence and associativity. So what do we mean by precedence and associativity really? What we mean by this is a set of rules that we can follow to know what to do when we have multiple operators in the same expression, like in the example we have here. If they tell you to evaluate the result of this expression, if we don't have clear rules to follow, we might have multiple answers and we want to know which one is right or wrong. For example, one might want to do A and B first and then do C and then do D, but one might want to do E minus F and do B multiplied by C and then do things in different ways and get different results. Hopefully, you are seeing that this may be a big problem. What we get from precedence and associativity is the rules we can follow to know which operator we have to do first. For example, in C++, the multiplication and division operator have to be done before you do addition and subtraction. And if you want to evaluate this expression here, you're going to have to do B and C first, and then do D and E. Once you have those results, then you can do addition and subtraction. But the question remains still. What do we do first if we have only addition and subtraction in an expression? And we solve that problem with associativity. Associativity defines if you do the operations from the left or from the right. And again, these things might not make sense yet. We're going to do an example and you're going to really see what is meant by this. To summarize, precedence tells you which operation you can do first, and associativity is going to tell you in which direction you're going to go, from the left or from the right. And some operators are going to be left associative, and that means that you're going to start evaluating them from the left. Some operations are going to be right associative, and you're going to start evaluating them from the right. And I am not making these things up. There is actually a C++ operator precedence table that you can consult to know which operators you should do first if you really are evaluating this thing with your mind. Okay, for example, if you look in this table, there are many operators we haven't seen yet, but that's not the problem. The most important thing here is to know what precedence and associativity are, and when we get to learn about these new operators, you can come here and know where they sit in this precedence table. For example, we know how to do addition, multiplication, and modulus. We see that the precedence for multiplication, division, and modulus is higher than for addition and subtraction. And we can use this in our operators to know which one is going to be evaluated by our compiler first. Another thing I want you to notice in this table is this column here on associativity. If you go back to our familiar operators here, you're going to see that these operators are left to right. So you should start evaluating things from left to right. But some operators have right to left associativity. And when we get to these operators, you will start doing things from right to the left. Okay, I think it is time we went to Visual Studio Code and actually played with these things. Here we are in Visual Studio Code. We are in our working folder. We are going to grab our template projects. We're going to copy this and put that in our lecture on precedence and associativity. We're going to put that in here. We are going to open this project in Visual Studio Code. We are going to get rid of things we don't need and remove this here in the body. And we are going to put in our test code so that we don't have to type this and save on time. We have a few variables here, A through G, and we have an expression here or a statement that is combining multiplication, division, addition, and subtraction. And we have to figure out which operation we're going to do first. I would challenge you to do this in your mind and try to guess what the result is going to be before we run this in our compiler. We're going to compile this with GCC, and we are going to open our terminal here. And if we do dir, we're going to see that we have rooster.exe. If we run it, we're going to see that the result is 30. How did we come up with that? Well, the precedence and associativity table says that multiplication and division have to be done first before addition and subtraction. We are going to take B and C and multiply those. So B and C multiplied, we're going to get a 24. We're going to try and do this in our brain. D divided by E, we're going to do that. So D divided by E, we're going to get a 3. So we're going to have a 3 here. And after we have this, we're going to do addition and subtraction. So we're going to take A and add that to the result of B and C. So we're going to say 6 plus 24, which is the result of B and C. We're going to minus the result of D and E. And we're going to do minus here. I hope you are following. And then we're going to minus F and plus G. We're going to minus F, which is 2, and do a plus G, which is 5. Okay, so this is our expression here. And now that we have this, we have to think about how we're going to do this. We can try to do this from the right, do 2 plus 5, and then do 3 minus 2 plus 5, and go from right to left. But our associativity table says that addition and subtraction have left to right associativity. So we will start from the left. So we're going to do 6 plus 24. We're going to get 30. We're going to minus 3, and we're going to get 27. We're going to minus 2. We're going to get 25. We're going to add 5. We're going to get 30. I hope you are following. And we are really following the rules from our C++ operator precedence table here. Okay, so this is really how you would use this precedence and associativity rules to evaluate your expressions. Okay, here I have another example for you. So try to evaluate what we're going to get from this expression here. We have A divided by B divided by C plus D minus E plus F. Try to do this in your brain and try to guess what we're going to get from the compiler if we print this out. We're going to put in our stdc out statement here, and we're going to try and build this with GCC, of course. We're going to run rooster, and you're going to get a 24. So how did we come up with that? We're going to start by division and multiplication. And again, where do we start? Do we do B and C first, or do we do A and B first? Well, we can check our precedence table here, and we're going to check the associativity of multiplication and division. We're going to go to this entry here, 13, and we see that it is left to right associative. These operations here are left to right associative. So what we're going to do, we're going to start from left and go to right. So we are going to take A and divide by B. If we take A divided by B, we're going to get a 2. So let's type that here. Then the result of that is going to be multiplied by C. And if we go up, we're going to see that C is 8. So we're going to multiply by 8 and get 6. So we can replace this with a 16, and we should be here. Then we're going to add D. D is 9. Then we're going to subtract E, which is 3. Then we're going to add F, which is a 5. So we have 16 plus 9. This is going to give us 25 minus 3. Okay, by checking this out, I see that I made a mistake. F is not 5, it is a 2 we have here. And if we do this from left to right, because addition and subtraction are left associative, we have to do them from left to the right. We're going to take 16 and add a 9. We're going to get a 25. Minus 3, we're going to get 22. Plus 2, we are going to get 24. And that's what we have here. I really hope this makes sense. Okay, so we have seen how we can use this precedence table, but sometimes you want to make it really clear which operations should be done first. And you can do that by using parentheses around your expressions. Let's grab the first expression here and do it again. We're going to copy it and go down and put that in place. And we're going to store the result in our result variable. And notice that we are reassigning these things to the result variable so that we don't have to declare another variable. I think this is clean, and that's what we're doing here. So what we can do here is make it clear that we want multiplication done first by using parentheses, and make it clear that we want the division to be done first. And when you do this, the compiler is going to see that you want this operation here done first. And that's what it is going to do. And if we print result again, we're going to get exactly the same thing we had before. stdcout result. And we're going to put result out. And let's make it clear that we are using parentheses here to signal which operation we want to be done first. We can compile this with GCC. We're going to run the task to build with GCC. And if we run the program, we're going to see that the result is 30, exactly what we had before. But now it is very clear to the reader of this piece of code that we want B and C done first. They don't have to go through the precedence table to really try and figure this out, potentially wasting precious time. Another thing you can do with this is, for example, what if the precedence table is not working according to your needs? For example, you really want A and B done first. You can specify this with parents here. And what this is basically going to do is going to force the compiler to do this first. It's no longer going to do B multiplied by C and D divided by E. It's going to evaluate this first, then it's going to follow the order in the precedence table that we have seen before. So try to guess what we're going to get now. And I am going to run the code and we're going to go through this together. So let's run task and we're going to run rooster. Now you see that the result is 72. What is happening here? Well, let's go through this line by line. We are doing A plus B, which is 9. So we're going to get a 9 here. We're going to put that here as a comment. Then we're going to multiply that by C. So we're going to do 9 multiplied by 8, and that's going to yield a 72. And by that time, we're going to be here, and we're going to do the division first, D by E. Then we're going to take 9 and divide by 3. That's going to yield a 3, so we're going to have a 3 here, minus 3. We're going to minus F, which is a 2, and we're going to do plus G, which is a 5. If we evaluate this, we're going to get 72 minus 3, which is going to be 69. Minus 2, it's going to be 67. Plus 2, it's going to be 72. And that's what we have here. Hopefully you can see that using the parents, not only can you make it very clear which operation you want to be done first, you can also define the rules that are prescribed by the precedence tables that are defined in C++. I hope this makes sense. And this is really all we set out to do in this lecture, to learn a little more about precedence and associativity. And my advice to beginning programmers is not to rely on the precedence table too much. It is to try and make your intent very clear using parentheses. And anyone reading your code won't have to go check these rules in their reference C++ documentation. They are going to directly understand what your expression is going to do. And that's a good thing. Readability of your code is really something you should strive for. This is really all we set out to do in this lecture. I hope you have a better idea about precedence and associativity. We are going to stop here in this lecture. In the next one, we're going to learn about some cool things we can do with addition and subtraction. Go ahead and finish up here and meet me there.